Have you ever wondered while scrolling your feed and you come across a video from ESPN about your favorite basketball match with a highlight reel, and you're wondering, oh, how did that particular moment in the match or the game impact the rest of the game? Or you come across a lovely looking picture on the feed from your friend about a particular dish that they've cooked, and you want to really understand what's the recipe? How do I find these ingredients? Or maybe you find an interesting factoid and you want to understand more about that particular topic, or you see a post which is super funny and a meme that's funny to everybody in your friend circle, and you kind of have still not figured out what it is. You're not getting the pop culture reference, and maybe you need a hand to understand what's going on. Well, look no further. We've got Feed Deep Dive now on Facebook app for you, which solves most of these things and more, and brings AI to your feed experience. Before we go further, let me introduce myself. I'm Jubin. I'm the engineering lead for Facebook Feed. I really enjoy building engaging products for our users. On the technical front, I love leveraging AI for software engineering, so automated testing, as well as improving the efficiency of our code base. Small changes that can make our code run more efficiently, reducing CPU cycles, and effectively lowering carbon footprint as well. And outside of work, I really enjoy running and cycling. I run with my children on the stroller. We've done about 15,000 miles. And I also love guide running with disabled athletes as well. So with that said, let's straight jump into the context and take you back in time to when Facebook came to the fore back in 2004. It was an app with status message updates and pokes. Remember those? Seems like those pokes are making a comeback in 2024 now as well. But then in 2005, we brought photos to the app. The feed came along after that. And then jump forward about another decade, and you have Facebook Reels coming to the fore as well. The apps become very multimedia heavy, very much about videos and images. And it's kind of a callback to our text origin comes with when we bring text models to the fore as well. So we moved on from being a digital yearbook to an entire platform now. So while at the same time, there's been vast advances in the world of AI and generative AI. In 2017, you had the Transformer paper come out. You had the biggest kind of big breakout moment was the launch of ChatGPT, which really got the world's attention. And then in 2023, you had a lot of different foundational models coming to the fore from Google, from Anthropic, from OpenAI, from Meta. We open sourced Llama 2 as well then. And then fast forward to 2024, products leveraging generative AI as well. A lot of chatbots coming to the fore. Bard/Gemini. You have Claude, you have ChatGPT. We also have Meta AI from Meta that came to the fore. And in 2024, we brought Meta AI to Facebook Feed. Today's talk is about the short 2-month journey to bring a product effectively from nothing to a few billion users, all together on a product that's already used by a lot of people on Facebook Feed. So that's what it's about. Let me ground the discussion to a few concepts around what I mean by prompt, what I mean by responses, and so on. So prompts are effectively questions we feel a user might find interesting or relevant to ask to a chatbot to enhance their experience on the Facebook app. It could be something as simple as you see a post about your friend having a nice pasta in Italy with a bunch of landmarks in the background. And you have a question about where is this place? How do I plan my journey to this place? What's the recipe for that particular pasta they're having? How do I buy the meal prep equipment or whatever it is? And so the prompt is AI generated. The response is AI generated as well. And while doing this, we want to make sure that paramount is that we have the response free of hallucinations. The last thing we want is on a post in Rome, we're showing a prompt about the Eiffel Tower. That just takes away from the experience. At the same time, we want to make sure that we're able to bring this at the scale of Facebook at a low latency and are mindful of capacity, and it's relevant and useful to people from across the world with lots of different languages, lots of different cultural nuances. Making a chatbot aware of these is an uphill task. So I'll talk about how we achieved all of these. Let me give you a quick demo of what the experience looks like. So in the simplest form, you have a post here with a video of somebody playing a bunch of jazz chords on the guitar. And the prompt is about, well, hey, I want to learn about jazz chords. How do I learn? And the chatbot gives you a very quick mouthful about a starter answer to that question. And then you can ask more follow-up questions and build out effectively how you're going to learn playing the jazz chord. This includes the AI understanding that it's a video about someone playing the guitar, they're playing jazz, taking some of the text context together and giving you an answer that's actually relevant and useful for you at your level of musical understanding. So if you're a savant at music, that question might have a different answer to if you were very much a new person to music. So that's about what the prompts and responses look like. Now to set the context of the talk, the two main topics. One is about the quality of prompts and responses, which is fundamental to the experience. And the other piece is around latency and capacity, which is around the challenges of scaling a product from 0 to 1 to a few billion users. And then finally, we'll talk about the key learnings and results, as well as what are the exciting things we're working on now that's going to come to the product in the near future. So let's dig into prompt and response quality. So fundamental to making any experience on a product like Facebook feed engaging is to make sure that the prompts are interesting and they're relevant. That's the minimum bar of the experience. But alongside this, equally, if not more important, is to make sure that the prompts are and responses are free of hallucinations and also don't lead to refusals or redirections, it's not a great experience if the chatbot refuses to answer the question or gives an answer to a different question or partially answers the question. So we want to make sure that we are giving the full experience, and we measure the quality of the responses via the 3H framework: helpfulness, harmlessness, and honesty. So we want to make sure we have a high bar of these. Along with doing all of this, we want to make sure that the responses are current and fresh. They are not a stale response which is linked to the training cutoff of the model. We need to make sure that the response is as fresh and current as possible. Otherwise, the user is not going to get engaged. And then finally, we have to, while doing all of this, we need to maintain a high bar of safety and integrity. That is a non-negotiable. So let's talk about how we do this. So I think if there was only one thing you take away from the talk, it's around context enrichment is king. Context enrichment is absolutely the key to solving all of the challenges I spoke about just now, and for any product that you want to bring to market that leverages generative AI. So let's dig into this a little bit. We've already got things like video subtitles, image and video optical character recognition, a bunch of multimedia understanding, which has been built over the years for ensuring that the experience on Facebook app is safe, is relevant. We use these for integrity as well as for relevance and ranking. So we have a bunch of mature signals around understanding the multimedia in the post, the images and the videos. We also leverage upcoming visual language models to semantically understand what's happening within the image or within the video. So combining these signals together helps us make sure that we meet a high bar on the 3H score that we spoke about. So essentially, if you look at the diagram, what we're doing is we take the post at creation or edit time, we perform a multimedia inference, getting all of these signals, and then we pass this context on to the response model. So we pass the post, we pass the prompt, but we also pass all of this multimedia understanding so that the response model is able to have all of the context to answer this question and to ground itself. Apart from that, then the other technique we use is to leverage real world context. And by real world context, what I mean is making sure that we not only rely on the content of the post and its multimedia understanding, or not only rely on the training of the response model, but we also leverage what other sources of information that are reliable. So in this case, what we would do is we essentially take all the context from the previous stage, figure out what the intent of the question is. For example, if it's a question about what's happening next in this particular basketball game, well, we have all the context of what game it is. We kind of inferred that from the previous stages, but now we need to know what happens next in the game. And here what we do is we would leverage a couple of sources. We have access to live scores of several sports. We also have things like live weather information and all those kind of real-time knowledge-based source. We can also perform a search engine query. So we have to figure out what's the right search engine query to make based on all the context. So distill all of that prompt into a few keywords to a search engine, which would essentially in this case be basketball game between team A and team B in so and so date, and give me a match analysis. And that would return a bunch of results. We would make sure that they are all high quality results and then follow and crawl the results that are most relevant, summarize those results, and pass that summary on to the response model. So now the model not only has the multimedia context, oftentimes the video transcript and what's happening in the game, the commentary, but it's also got kind of more macro understanding of what really happened in that match. So the response will be then contextualized, and the responses can also then point out to these links that the user can then go and follow. So that's essentially how we leverage real-world context. Apart from this, it's also very important to make sure that you're constantly monitoring how you're doing on quality scores. So once we formalize our 3H scores, we have human rating. So human beings are rating sample drive traffic on these different dimensions. We also trained LLMs to be able to do it on samples of live traffic. So a combination of humans and LLMs are rating the traffic on how we are doing on 3H scores. Apart from that, we're also leveraging the user flywheel effect. So what users found interesting and they're spending more time asking questions about decides what future interactions for that user and other users would be like. So we leverage U2U and U2M models to make sure that similar prompts to what people found engaging are what's shown to them in the future, with a bunch of like diversity rules in terms of like mixing it up so that it doesn't become pigeonholed or doesn't go into one single rabbit hole for the user. So yeah, combination of auto evals using LLMs, human rating, and usage feedback is what powers the flywheel. Moving on to scaling, and here I'll talk about latency and capacity. So let me first contextualize what the latency bar is for a product like Facebook Feed. So Facebook Feed, any operation that takes more than a few hundred milliseconds takes away from the user's experience. Users are tuned for everything usually responding in a few hundred milliseconds. Otherwise, users tend to move on to other actions, scrolling deeper in the feed or moving on to Marketplace or some other tab, or they might abandon the app completely and go on and do something else. So we need to make sure that everything is in the few hundred milliseconds range. If not, worst case is a second. We also need to make sure that the experience is like free of reliability issues like crashes and glitches and so on as well. So we track latency and track reliability, and we really focus on making sure that there's a high bar maintained here. And I'll talk about how we tackle latency in a moment. The other constraint is around cost. So just to give you a context of scale, usually for post-prompt multimedia context, it runs into a few hundred input tokens and leads to a few thousand output tokens. And at the scale of Facebook, given the number of posts and number of users clicking these posts, it runs into a few tens of millions plus cost in terms of server capacity if you compare this to any other cloud offering. So the cost of GPU inference kind of scales up quickly as well, and that impacts the CapEx and OpEx as well as our carbon footprint. So being very reasonable about this is very important. Now, there are a few tailwinds, and this is a key lesson on like looking at your usage pattern to figure out how do we get around these issues. I mean, this is a learning that applies to anybody building a product at scale. Because of the distribution of traffic, things that go trending or go popular tend to get more and more fan out. And on a platform like Facebook, you have few thousand posts end up getting the majority of the traffic. And the same pattern applies to what people want to deep dive about. On the same post, most users who view the post ask more or less one or two of the prompts. So we have a very skewed distribution on what posts are getting distribution. And then we have a few prompts that get the most impressions or most clicks on it as well. So we can leverage this to our advantage. We also observe that the top 50 odd prompts that are clicked on any one day or any 1 week constitute a vast majority of all traffic going to the LLM as well for responses. So knowing all of this, so the first way we do this is caching, right? To just run through current architecture. We've got the user coming along, asking a question. So we do intent detection, we add multimedia inference, and context to it. We pass all of that context to doing a search engine query, and we pass all of that context to the response model to give you a response. Now, all of these stages have a built-in latency, especially the search engine stage, because you're not only making a search engine query, you're doing crawling in most cases in real time. So to shorten this, we can use the usage pattern to our advantage. Because most people are prompting on the same posts or similar posts, and they are asking more or less the same question, we're able to start caching the responses. One of the ways we leverage the cache is essentially check for a cache hit on any new prompt request. And if there is an entry, serve from cache. Otherwise, do the entire workflow. And there are a few interesting practical ways of segmenting the cache I want to call out. One piece is that we want to still make sure that the response is reasonably relevant and we're not giving away on the quality of the response. So we want to make sure that the response is somewhat closely still relevant to the user and not lost at the bulk. So we segment the cache by things like region, things like user persona, so that the response is still fairly relevant to the user. The other thing we do is we also make sure that we want to keep a certain amount of freshness and quality by making the responses current. So by caching, you're going to make the response slightly stale. And the way we solve for this is we look at the intent of the question. For example, the question is about the score for a live game. You want to make sure that you're keeping the cache entry, the time to live, or TTL, short or almost current. Whereas for somebody asking for a recipe of a meal, which is mostly static information, you can have a much longer TTL. So by tuning the TTL by intent, you can get a good, efficient frontier on freshness versus essentially response latency. And that's kind of what we do. We basically end up leveraging this to our advantage. Finally, we also leverage a different approach around how prompts are generated. So we see that for a single post, it takes about a second to generate the prompts that are relevant to the user. Now, most users who are looking at Facebook feed end up having 10 to 20 posts per page, 5 or 6 pages. You're looking at 80 to 100 different posts. So computing all this in real time would end up becoming a very long process, and the latency just doesn't work out. So what we need to do is do some kind of pre-computation. Now, when we do pre-computation, we not only solve for latency, but we also solve for another problem, which is the distribution of traffic. There are peak times and there are off-peak times for any product, especially for Facebook app. It's a very choppy traffic if you look at online patterns. What you can do is make sure that the pre-computation fits the off-peak traffic. So you use asynchronous tier of machines to do your inference, where you can tolerate a longer latency, and you can make sure that you don't have to have as many GPUs that serve both the online and the offline traffic. So by going offline or asynchronous, you're able to also reduce the number of GPUs in general you need and reduce your GPU cost in that regard as well. So we leverage these two techniques around caching and pre-computation to reduce our cost as well as improve our latency. And that's how we kind of brought this product to scale. Now, a couple of other, finishing off by talking about the key learnings and then what's coming up next. So key learnings for us, I think the key learnings are around the fact that context enrichment is king. I said that at the beginning. It's key for any product coming to market. It helps reduce hallucinations and make sure that the context is relevant, helpful, and interesting. But apart from that, we also see that there is a few interesting takeaways. The one takeaway we see is that wherever humans are involved in the cycle of product development, whether it's human rating, red teaming, you're going to see a lot of bottlenecks. So wherever you can automate these, you're going to see huge improvements in how quickly you can iterate. And the other thing also we learn is that leveraging the usage signals, what people are finding interesting and not finding interesting, whether it's measured via time spent, via follow-up prompts, via how often they use the product, using that to create a flywheel and applying ranking and relevance techniques can really dramatically improve the product. And finally, what we also see that what's popular or what kind of content works on Feed Deep Dive is around sports, hobbies, current events. But I mean, the other takeaway was also that memes and humor continue to be the things that go viral on Feed Deep Dive, much like they do on the rest of social media. We are finally at the last step, which is actually the most exciting step, which is around what's coming up next. So the biggest piece is the advances in generative AI actually line up nicely with what Facebook app is about around media and the heavy use of videos and images and now voice. So multimodality and models that are good at video understanding, voice, as well as persona that's kind of tuned to the kind of experience the user wants to have, whether they want to have a conversational AI or an AI that's better at deep diving and education, or an AI that's good at imagining or imagining images or creating images. So generative, educative, or conservation, conversational is what we want to see. The the other few learnings are also that there's vast amounts of data sets that can help better ground responses. We've got tons of content on groups around people asking questions and other people answering them, which can be the same questions that users are asking Feed Deep Dive. So leveraging groups content and also offering reels which answer the question. So responses can get much richer with reels content, which people find engaging. And finally, around how do we make prompts better and better? And we see that leveraging agentic and leveraging reward models, chain of thought, these are technologies or approaches, techniques that actually make the prompts much more engaging and interesting to the user and much more tuned to the topic of the post and the persona of the user. And finally, what we see is that what we are working on is around engineering and scaling. Challenges continue to be important. So we can still continue to drive down latency. We can still make the use of GPUs more and more efficient by going into a few different techniques around making the inference efficient, or also the amount of QPS we need to make to a GPU less as well. So this is, with all that said, it's an exciting time on Facebook app and Meta AI. And that's what I'll leave you with. Thank you very much.